All right, today 8.3, day 2 is continuing compound interest. Today we're going to be looking at our last formula on the formula sheet, which is the effective annual yield. This is the simple interest rate that is producing the same amount of money in an account at the end of 1 year as when the account is subjected to compound interest rate at the stated rate. So when we're finding the effective annual yield, we are always going to be getting a percent. That will be close to the original rate, but slightly different. You'll know that it's effective annual yield formula because it's the y equals. So anytime I ask you to find the effective annual yield, you'll see that word yield, you'll know y equals formula is the one we should be using. Variables are the same as they've been. R is our rate as a decimal. N is the number of times compounded per year. So remember that it could be annually is 1, quarterly is 4. Let's see where I have that. Semi-annually is 2, monthly is 12, and daily is 365. So depending on what the question says, we will fill that in. And then don't forget that there's this -1 at the end. Okay, also you may want to note, at the end of the problem, convert to a percent by either multiplying by 100 or moving your decimal 2 spaces. All right, so example 1 says a savings account has a nominal rate of 7% with interest compounded daily. Find the account's effective annual yield. So again, because it says yield, we are using the y equals formula. So in this case, we don't need to know what the principal actually is. We are just going to use this formula to find out what our effective annual yield is, which remember that just stands for the simple interest rate that produces the same amount of money as the compound interest rate would. So our nominal rate was 0.07. They ask us to do daily compounding, which is 365. So we plug those in. Don't forget this -1 at the end. That's one thing I see a lot of students forgetting at the end. And we just punch that all into our calculator. So we'll have 1 plus 0.07 divided by 365. Caret to the 365 power. Now, on your graphing calculators, especially if you have the new ones, make sure you arrow over to get out of the exponent before you put the -1. You will get a much different answer if you leave it in the exponent. I'll show that in a second. And hit enter. Now remember, that is not our rate because right now that's as a decimal. So we need to convert that by either multiplying by 100 or moving your decimal 2 spaces. So our final answer should be 7.25% or 7.3%. I usually round to the nearest tenth. Now let me just show you what would happen if you did not arrow over, like I said. You will get something really big. Okay, so just be careful that you do make sure you exit out of the exponent before you put the -1. You also could, to be safe, you could just type this in the calculator, get an answer, and then subtract 1 from it as well. Next one, we have, again, an effective annual yield. Interest rate was 8% and compounding it quarterly. What does quarterly mean? N would be what? 4, correct. So R is 0.08, N is 4. We'll plug in our values using our calculators. Should get 0.0824. Again, change that to a percentage by either multiplying by 100 or you can just simply move the decimal place over 2 spaces and we should get 8.2%. So you'll notice that the interest rate is actually slightly higher than the nominal interest rate, but it's going to be very close. Okay, our last one was just slightly higher than 7%. All right, then the last type of problems we're going to see today are using the formula from yesterday with our A equals But we're going to be solving for P this time. In the 8.3 day one, I always told you what P was, and we found A. Today we're going to find P, which is the amount that is needed today as principal to obtain a future value. So essentially what we're going to do is we're going to take the formula from yesterday and we're going to solve it for P. So if I wanted to solve this equation for P, I would need to undo the operation that's going on between these two things. What operation do we see between P and the parenthesis? Good, it's multiplication. What's the inverse of multiplying? Dividing. So we're going to draw division bars on both sides of the equal sign. We're actually going to divide by this whole thing, which I know it looks crazy because it's so big. But if this were P times 2, we would divide by 2 on both sides to get P alone. So we're going to divide by this whole quantity on both sides. What happens is these cancel each other out. So we end up with this equation, P equals A divided by, oops, a little typo in my presentation. Sorry about that. We should only be dividing by the 1 plus R divided by N to the NT power. Leave the P where it's at. So I'm just going to cross those out. And this is the new formula that you'll definitely want to make sure you jot down before you take your mini quiz. It is on the formula sheet if you open the formula sheet while you're taking the quiz as well. So example 3 says, how much money should be deposited in an account that earns 9% interest compounded monthly so that it will accumulate to be $15,000 in 7 years. So if this is our future value, that is our A, not our P. We're actually looking for P because it says how much should we deposit, which is our P value. We're saying that our P value, we don't know what it is. Interest rate's 9%, compounded monthly, which is 12. So 12 for N, 0.09 for R. And 7 years, T is 7. So again, because we want to find P, we're using the other form of that equation, P equals, that we just wrote. Substitute in our values. A goes in the top, N and R and T go in the bottom. And I would like you guys to all try this on your calculator, especially before you take your mini quiz, because a lot of students lose points because they type it in their calculator wrong. Again, you may want to add parentheses around the 12 times 7 just to be safe. We should get $8,007.68. So we need to put that amount of money in right now so that in 7 years it'll be equal to $15,000. So you guys can go ahead and try the closure. How much money should be deposited in an account that earns 5.5% compounded semi-annually so that it will accumulate to $10,000 in 10 years? Go ahead and pause the video now, and whenever you're done, press play and you can see the work. All right, so going over the closure, we can see that our interest rate is 5.5%. Our A value is 10,000. We're looking to do this semi-annually. Semi-annually is twice a year, and is 2. R is 0.055, and T is 10. Since we're looking for what P is, we're using that new formula again. And plugging in our values, we should get $5,812.51. So again, when you guys are doing your mini quiz, I don't have the 8.3 one up yet, but I'll show you guys on the 8.2 quiz. I will put the formula sheet attached right next to the sign-in, so if you want to open that up in a separate window while you're taking it, this is the 8.2 formula sheet, but I'll be posting the 8.3 along with this video. You can have those open kind of in 2 separate windows while you're taking the mini quiz, if that helps. So make sure you complete the 8.3 assignment as well as the 8.3 mini quiz. And if you guys have any questions on the homework or the notes, please just shoot me an email and I will get back to you.